Okay, so one important special case of our formula for A of t is when t0 equals 0, t1 is some time after our initial time of t equals 0, and we're making one single deposit into the account at time t equals 0. Okay, so A of t0 is just A sub 0. And here it's going to be the integral 0 to t of delta t dt. And yes, I must confess my sin here that if I have t as one of my limits, I really should have like delta u du or delta x dx, anything other than t. But I mean, I'm hoping I don't offend any math purist by writing this. Certainly if you want to write, if you don't like this, you can write delta u du, delta x dx on quizzes or exams. And I'm more than thrilled to see that. I'd be frankly really thrilled that you understand that distinction. But anyway, I hope it's not going to cause any confusion or anything. So for example, in this case, implicitly in this case, where we have one single deposit at t equals 0, let's find what A of t is. If delta of t is equal to 2t.
Okay, so here, if the force of interest delta t is 2t, then just dump into my formula. Well, actually, before I just dump into the formula, let's just do the integration. So if I do the integration, I'm going to do 0 to t delta t dt. So it's 0 to t 2t. And again, I really should, for the math purists here, I should have, a integration variable separate from what's here, but hopefully that doesn't, again, make anyone too upset. So this is going to be 2t squared over 2, 0 to t, and that's just going to be t squared. So plugging in my formula, we get A of t is a naught e to the integral 0 to t delta t dt. And that's just simply, well, we just did this integral, so it's just a0 e to the t squared. All right, so as a sanity check here, let's use our formula to recover the compound interest and simple interest formulas that we had many videos ago for A of t, where we're just looking at exactly the situation here, where we start off at t0, t0. Well, we start off at t0, and then we just have one single deposit at time 0. Okay, so yeah, let's recover these these formulas that we had before. So let's first do compound interest. That's quite a bit simpler. Okay, so remember we computed in the last video a constant force of interest, ln of 1 plus I. Okay, and right, so let's just plug into our formula, and it's going to be a lot simpler than it might initially look. So this is 0 to t of ln of 1 plus I dt. Well, I'll just, well, maybe not do it separately. So here, this is just a constant. So I can just take this constant, pull it outside. And if you prefer, you could just do this integral first and then plug into the formula. I think I've done that enough times, particularly for a problem like this, where it's not necessary. But so this is going to be ln of 1 plus I integral 0 to t dt. Well, you integrate dt, you just get t. And let me put this in a bracket here so that it doesn't look too messy. So this is just t, 0 to t. Well, plug in t, you get t. Plug in 0, you get 0. So it's just t minus 0. So that's just t. Okay. And I'll just stick that out in front, make it look a little more familiar. So you should, so yeah, I'm just taking basically this here and just sticking it out, sticking it up front. So this should, you should know what to do here, and that what I'm going to do is I'm just going to use the properties of exponents, or rather the natural log properties, and bring it upstairs. Certainly I'm allowed to do that. So here we have e to the ln of this whole smorgasbord here. But e is going to undo the ln. So this is simply going to be e undoes the ln. It's a naught 1 plus I to the t, which is exactly our original compound interest formula. So for simple interest, well, it's not so simple. Though if you're a math major, it's still a pretty darn easy integral. So remember, force of interest is I over 1 plus IT. So let me just get this integral first here. Otherwise, it's going to get real messy real quick. So just do this integral. And I'll do this a little slow for particularly the economics students. So I'm going to first pull out my constant. I is the constant interest rate. So, so it's just dt over 1 plus it. So that. Okay, so let me do it in red. So it should be obvious what to do, certainly if you're an actuary major. And the only reasonable thing to do is do u is I plus t. So that means differentiate, you get I, so du is I, du dt is I, so du is I dt. So du over I is dt. Okay. So I'll handle the limits in a second. So, right, so we have the I, maybe move this down a bit. So we have the I here. We have dt, so maybe it's a little easier to write it as 1 over 1 plus it dt. Not that it matters all that much, but so we have the dt, and that's du over I. So u is 1 plus it, so it's just 1 over u. Okay, so whenever we do a substitution, we have to ask ourselves, what is u when t equals 0? Well, when t equals 0 here, it's 1 plus I times 0, which is 1, plus 0, which is 1. What happens when we have t here? Well, nothing happens. this here, when t is t, u is 1 plus it. So instead of t here, it's u, which is 1 plus it. Or rather, sorry, maybe that's a bad explanation. Again, it's all we're saying is, well, what does u become when t is t? U is 1 plus it. So it's 1 plus it, and we cancel out these constants. And so this is going to be 1 to 1 plus it du over u, which is ln of u, really ln of absolute value of u, but anyway, not going to worry about that. Okay, so just dump in here ln of 1 plus it minus ln of 1, and you should know ln of 1, it's just going to be 0. So this is just ln 1 plus it, and you can probably see where this is going. So just dump into our generic formula, a 0 e to the 0 to t, force of interest dt. We computed this integral just a moment ago to be ln of I times ln of 1 plus I times t. So the E undoes the ln to get our familiar simple interest formula A naught 1 plus I t. So last but not least, let's do a example that was I don't know how long ago, but do an example that was an exam FM problem. This is not too bad of an example.
One thing this example makes clear is that you should review piecewise formulas, particularly as it pertains to integration. So a customer is offered an investment. Interest is calculated according to this force of interest. Delta sub t is 0.02t, t is between 0 and 3, 0.045 t is bigger than 3. The
Initial investment is
1,000. What nominal rate of interest compounded quarterly is earned over the first 4-year period? So when we say this, when we
to speak of a nominal rate of interest, this is an actual number. We want the equivalent nominal rate of interest for this 4-year period. And compounded quarterly means what it colloquially means, that interest is compounded 4 times a year. Okay, so for this problem, to start working towards getting the nominal interest rate compounded quarterly, which is 4 times a year for this time period, this 4-year time period, we need how much is in the account after 4 years. And we only have one single deposit at t equals 0, so our formula applies. We have a $1,000 deposit at the very beginning. So it's 0 to 4 delta t dt. All right, so let's get this integral here. Again, just to make this much less messy, and so I don't have to write 1,000 e to the whole thing at each step. All right, so our function here is a piecewise function on these two intervals, 0 to 3, and well, 3 to 4, because we are interested in how much is in the account after 4 years. So we're going to break the integral up into those two intervals. So basically, we're doing this just like you would in Calc 1 if you're integrating a piecewise function. Hopefully, you should have integrated such functions in Calc 1. Right, so 0 to 3 and 3 to 4. Right. Okay, well, between 0 and 3, this is going to be 0.02. That's what we're given the function is, 0.02t, sorry. And after 3 years, we're given, it's a really bad looking integral sign. We're given that delta t is 0.045. Okay, so, right, so this is very simply, you integrate 0.02t to get 0.02t squared over 2, sorry. Integral t is t squared over 2. So this is evaluated between 0 and 3, and you integrate 0.045 to get 0.045t. Between 3 and 4 to get, well, this is going to be 0.02 times 3 squared over 2 plus 0.045 times 4 minus 0.045 times 3. Or if you want, I mean, you can do these in definitely simpler ways, but whatever. Yeah, sorry about that. So yeah, I should just plug in 3 here first. And then plug in plug in 0 first. Okay, whatever. You get 0.09. And obviously, I don't need to see this much work on a quiz or exam. 0.045, 0.135. So go back to what we had here. I'll just write on another page. We got this integral to be 0.135, so a of 4 is right, 1,000 e 0 to 4, force of interest, 1,000, which is 1,000 e to the 0.135. So it's 1144 and roughly 54 cents. Okay. Right, so what we're going to do is now we're going to get, well, first let's get the 4-year growth factor, and then we'll get the 1-year growth factor, and then we'll just use our formula for nominal interest in terms of the 1-year growth factor. All right, so to get the 4-year growth factor, let's see how this fund grew in the 4 years. So it grew to 1144 and roughly 54 cents, and we start off with 1,000. So the growth factor is going to be, well, 1.14454 over the 4-year period. And to get a 1-year growth factor, well, we just raise it to the 1/4 because, well, 1/4 of a 4-year period is 1 year. So we take 1.1 for 4.53 678, and I'll actually create a new oops, sorry about that, 1.14454. I don't know what I was doing right there. My voice said something and I was thinking something else. Anyway. Yeah, and I'll create a video on how to go from interest rates from one period to another period, and growth factors from one, or from interest rates from one time period to another time period, and growth factors from one time period to another time period. That's something I think in previous courses I didn't really talk about enough, and well, most students basically picked up on how to do it through me doing it via examples throughout the course. Some never really did, so it's worthwhile. But anyway, yeah, I raised this to the 1/4 because 1/4 of a 4-year period is 1 year. So this is going to be 1.03 433, or you can also think, and you can, it's useful to think if you compound this growth factor 4 times, you'll get, well, the 4-year growth factor of 1.14454. And that's just reflected in raising both sides to the 1/4. Sorry, raising both sides to the 4th. That's going to get rid of this 1/4. So 1.14454. So the 4th is, oops, sorry, this equals what I have on the right, raised to the power 4. Okay, anyway, so this here, if I is my equivalent effective 1-year interest rate, then this is exactly 1 plus I. The 1-year growth factor is 1 plus the equivalent effective annual interest rate for this 4-year time period. Okay, so all I have to do now is plug into my formula for nominal interest compounded quarterly, which again means every 4 years. And that's just literally 1 plus I to the 1/4 minus 1. Dump this in here. So of course I is 0.03433, but maybe no need to get I by itself. We really want 1 plus I. So it's going to be, 1.03433 to the 1/4 minus 1. And this is going to be 0.03389. And if you do have the physical book, they rounded up to 0.339, I believe. Let's quickly check. I think it is 162. Yeah, 0.0339. So they just round the 8 up to 9. But all right, and yeah, I do like this problem because it incorporates force of interest and the idea of nominal interest and equivalent effective annual interest rate. And again, always put it in perspective. Why do we care about equivalent effective annual interest rates? Well, it just puts growth in perspective. We all, myself included, we all like to think and usually think in terms of yearly growth. So to me, something like 1% yearly growth or 1% effective annual interest rate is pretty anemic. Something like a 6% effective annual interest rate. Well, now we're talking. That's not so bad, actually. That's pretty decent growth by my standards, certainly. Especially if coming from someone like myself who doesn't really invest all that much. Probably should, but anyway. Okay, so remember that the practical meaning of the relative rate of change over some time interval from t0 to some future time t1 is that the percentage growth over this time interval is given by the relative rate of change times change in time converted to a percentage, meaning you multiply by 100%. And so remember the example we did before is following, where if after 1 year we have $930, and if after 9 months we have $900, then the relative rate of change, just plop into the formula, is going to be 0.13333. Threes continue on per year. And so with this interpretation right here, what does that mean? That means that the percentage change over this 3-month time period from 9 months to 1 year is just 3.333%. Okay. And yeah, again, let's just quickly check that. It's actually checked already here, but right. So we start off with $900, not 9,000, but 900. And we grow by 3.3333%. So that means we take 900 times 1.03333. And lo and behold, we get $930. The threes continue on forever. So we're off by less than a penny. But yeah, so 900 grows by 3.333% in this 3-month time interval. That means we go from 900 to 930, which is exactly what actually happens. So what I want to do to end the force of interest is actually compare using the force of interest to approximate the relative rate of change via computing the percentage change over a small time interval versus actually computing how much you exactly have over a short time interval via this formula. And as we'll see, for small time intervals, it's pretty remarkable how accurate we are. Like relative to millions of dollars, we'll be accurate to $5 or $10. So, yeah, it's pretty interesting. And admittedly, this is not necessarily tested on Exam FM, but this to me is is really important in that it's practically understanding what on earth the force of interest gives you, what it actually means, and what the relative rate of change actually means. So let's say in this example, I have an account where after 2 years, I have $10 million. And let's say we have a force of interest that's given by 0.7 t. So that means that the force of interest, the instantaneous relative rate of change at t equals 2 after 2 years is just going to be 0.14. So that means we're going to have 14% growth per year for very small time intervals near 2. Okay? So as long as we're very close to 2, for very, very, very small time intervals near 2, we're growing. This fund is growing by 14% per year. Okay? So let's use that fact, that practical meaning of the instantaneous relative rate of change, the force of interest, to figure out how much is in the account roughly 1 day after 2 years. Okay. Okay, so if I have 14% growth per year, well, just like in the previous example, I'm just going to take 14% divided by 365. 1 day is 1 over 365 years. 14 over 365. So I got 0.03836. One second. Let's just round actually to 0.0384. Okay. Okay, so let's see how much we have in the account 1 day after 2 years. Okay. So I'm going to do that exactly the way I did it here. Okay. And if you want to go back, I'm going to have to get rid of this. But yes, get rid of this. And what I'm going to do is I'm going to compare this answer to the exact answer. We have the formula to get the exact answer. Really quick, that formula is right here. Right here. Not very illuminating, but this is the formula to get the exact answer. So 1 day after 2 years, okay, well, 10 million grows by 0.0384% per day. Okay. So we take 10 million, I think I said 1 million, 10 million grows by this amount here, 0.0384% per day. So divide that by 100, 0.00384, add 1. So 10 million times 1.00, missing a 0 here. Yeah, so it's let's see, make sure I get my zeros right. Yeah, so we have 1 0 here, so I add 2 more if I divide by 100, so it should be 0.000384. And I have 10 million. 10,003,800. So this is an approximate answer. So remember, the idea of the instantaneous rate of change, the force of interest, same thing, is that it approximately gives you the relative rate of change at t equals 2 after 2 years for a very, very small time interval. It's a good approximation, but still an approximation. Okay? And certainly one day, 1 over 365 relative to 1 year is a small time interval. Okay, so now let's compare this to the exact answer. All right, so A of 2 plus 1 over 365. Well, first let's just get that. 2 plus 1 over 365. So it's 2.00274. And we're going to get a remarkably close answer to this here. I think it's going to be off by 60 something cents. So, yeah. Okay, so this is going to be, we have our formula. A of 2 e to the 2 to 2.00. I forget what I had a second ago, but this is 2 years and 1 day. So the T0 is 2 years, T1 is 2 years and 1 day. Integrate that with the integrand 0.07t. So A of 2 e to the integral 2.00274.07t dt. So this is 10 million. E to the 0.035 t squared. To 2.00274. So let's get that. Okay. So take 2.00274 squared minus 2 squared, which is 4. E to this. I forgot to multiply by 0.035. Sorry about that. So 2.00274 squared minus 2 squared. And it's 0.035 because integral of 0.07t is 0.07t squared over 2. 0.07 over 2 is 0.035. Times 0.035. Okay. Now raise that to the e times 10 million. Right, so we get 10,003,839. Point 36 cents. Okay. So we're literally off by actually we're off by 64 cents. Okay. All right, so right, again, just to recap real quick, if still doesn't make sense. So I have after 2 years, 10 million. This is my force of interest function. So the force of interest, which is the same thing as the instantaneous relative rate of change, is 0.14 at 2 years, at t equals 2. So that means as long as we're very close to 2, we're taking a time interval really small, really close to 2, we're growing at a rate of 14% per year. So if I want to look at 1 day after 2 years, that's a time interval. 1 day after 2 years, between that and 2 years, it's a very tiny time interval, t equals 2 to t equals 2 in 1 day. Right? So we divide by 365 to get 1 day's worth of growth. So in 1 day, very close to 2, you grow by 0.0384% per day. So that means that 1 day after 2 years, well, you have 10 million times 1 plus 0.000384, 10,003,840. And using our formula to get the exact answer of how much you have 1 day after 2 years, we have 10,303,839.36. So they're exact same thing, except we're off by 64 cents. Okay. So, all right, hopefully that makes sense. There's a homework problem like this. So if not, just ask me questions. Yeah, all right. Hope this video clarified things. Have a great day. So long. Take care. Goodbye.